So next example, calculate I1 and I2 in the following two ports. So for this circuit, we are given the Z parameters and a voltage source in series with a resistor is connected to port 1 and then port 2 is shorted. Remember our for Z parameters, or V1 is equal to Z11 I1 plus Z12 I2. Then our V2 is equal to Z21 I1 plus Z22 I2. Now substituting the values given the circuit for our Z parameters, our V1 is equal to 6I minus J4 I2. Then our V2 is equal to negative J4 I1 plus 8I2. Now, looking at this left loop, this loop right here, applying KVL at this loop, we have negative 2 angle 30 degrees plus 2I1 plus V1 is equal to 0. So our V1 is just equal to 2 angle 30 minus 2I1. And then looking at port 2, our port 2 is shorted, so meaning our V2 is equal to 0. So using these values, this equation becomes 2 angle 30 minus 2I1 equal to 6I1 minus J4 I2. Then for the next equation becomes 0 equal to negative J4 I1 plus 8 I2. Equation 2. And equation 1, we can further simplify this. 2 angle 30 equal to 8I1 minus J4 I2. We have two equations, two unknowns. We can now solve for I1 and I2. So expressing these equations in matrix form, we have 2 angle 30 0 equal to 8 negative J4 J4 and 8. We have I1 and I2. So our A1 is equivalent to delta 1 over delta. Our I2 is equivalent to delta 2 over delta. So where our delta is equivalent to the determinant of the Z parameters. We have 8 plus J4 8. This is equal to 80. For delta 1, the determinant of 2 angle 30 0 negative J4 and 8. So this is equal to 16 angle 30. For delta 2, we have 8 negative J4, we have 2 angle 30 0. So this is equal to negative 4 plus J4 square root of 3. Now plugging in the values for delta 1 and delta 2, we can now solve for I1 and I2. So our I1 is equal to 0.2 angle 30 here, and our I2 equal to 0.1 angle of 120 here. So you can also solve this problem using the equivalent circuit for the Z parameters.